Tonight's topic is the composition of functions, also known as composite functions. And we're going to start with, we'll take a linear function here, negative 3x plus 5. And we're first just going to talk about some notation issues. If I want to evaluate f of 2, we read that f of 2, which does not mean f times 2. It just simply means that we're going to plug 2 in as an input, and we're going to evaluate this thing for some output. So f of 2 is going to equal negative 1. The end result would be that this is a point on the graph of negative 3x plus 5. Let's say I have f of negative 4. If I have f of negative 4 and I'm going to plug negative 4 in for x, negative 4 is the input, and we evaluate that, that gives me 12 plus 5, which equals 17. And I can do this all day with different values of x, but that really isn't what a composition or a composite function is. What we do is we're going to take this function, and instead of plugging in 2 or negative 4, now we're going to plug in, let's say we want to plug in 2x. What would that look like? Well, we're going to be doing the same thing. Anywhere I see an x, I'm going to replace it with an input of 2x. And so that gives me negative 6x plus 5. And that doesn't simplify any further. If I wanted to evaluate f of 2x plus 4, same concept, plug in 2x plus 4 wherever I see an x, and then just simplify as much as I can. I'm not going to get a numerical answer like I did up here, because I can only simplify this thing so much. And so this gives me negative 6x minus 7. Well, so what we just did was this. 2x in its own right, 2x is a function. And 2x plus 4 is a function. So let's just say, since 2x is a function, let's say that I want to call g of x, we're going to have another function, g of x is going to equal 2x. And so when I say f of 2x, when I write f of 2x, that's the same thing as writing f of g of x. And this is what a composition of functions is. It's taking one function and plugging it in for another one. Let's say with this 2x plus 4, I got to name that something different. Let's call that h of x. H of x is going to equal 2x plus 4. So when I evaluate f of 2x plus 4, what I'm really doing here is I'm evaluating f of h of x. And so f of h of x in this case is going to equal negative 6x minus 7. All right, so let's try this for another example now. Let's go back to our original function, f of x. And that function was negative 3x plus 5. And I'm going to come up with a new function now. Let's call it t. I'm just going to use a different variable, t of x. And t of x is going to equal negative x minus 6. And so what we want to do now is find the composition of f, of t of x. That's what I'm looking for. Well, that's the same thing as f of negative x minus 6, which means anywhere that I see an x, I'm going to replace it with negative x minus 6. So negative 3 times negative x minus 6 plus 5. Let me keep things in blue here to help you see what's going on. All right. And so now we just simplify this. This gives me 3x plus 18 plus 5. So that gives me 3x plus 23. So f of t of x would be equivalent to 3x plus, I put 2x, 3x plus 23. All right, now let's try one final one here. I'm going to have you try t of f of x. See if you can do that. Go ahead and stop the video and try it on your own, and then start it up again. Basically, t of f of x means that I'm taking t of negative 3x plus 5. And so I look up at function t here, and anywhere that I see an x, I'm going to replace it with a negative 3x plus 5. So it's going to be negative 3x plus 5 minus 6. And then I simplify this. 3x minus 5 minus 6, which is 3x minus 11. And that's the nuts and bolts, that's the basics, I guess, of composition of functions. And that's all for now.